All right, grade 12, 6.2 is characteristics of the equations of polynomial functions. So we're going to start with explore. How can you use the equation of this quadratic to predict the end behavior of its graph? So we want to know what this graph looks like. First thoughts, what can you tell me about this graph?
It's going to be a parabola.
It's going to be a parabola. How do you know? So a parabola, because it is degree 2. What else do you know? Does it open up or down? Opens down, up. Okay, so intercepts should be 40. And how do you know it's 40? Good, if you'd plug in 0 for these x's, you'd get 0 minus 0 plus 40 equals your y-intercept. So 40, or the constant, is your y-intercept. Good. And the x-intercept, how would you find those?
Y for 0.
You put y for 0. So if I have 0 equals x squared minus 13x plus 40, how can I figure out what x is?
Move 40 to
We actually don't want to move 40 to the other side because we've got two x's here that we can't combine. Factor it. Good. So if we factor it, we get x minus 8 and x plus 8. That was really bad. X minus 8 and x minus 5. So what are your two x-intercepts?
8 and 5.
Good. X equals 8 and x equals 5. Because those are the two numbers that you'd plug in here to get 0. Okay, and do we know where it starts and ends? What quadrant, sorry, does it start and end? Quadrant 2 and ends in quadrant 1. Good, and we can check this with a graphing calculator. So we've got standard form in all of these different, for all of these different functions. So linear, standard form is f of x equals ax plus b, where b is your constant and a is your leading coefficient. For a quadratic, it's very similar, except what should our degree be in a quadratic? Degree 2, or have an x squared term. So then our next term is bx, and we end with our constant of c. Cubic, what is our degree? Ax cubed plus bx squared plus cx plus d, where now d is our constant. So these just keep getting longer, but it repeats a pattern. So if you had a function to the power of 4, it would just have one more term on it. These are also some really important ones. Linear formula, y equals mx plus b, and vertex graphing form for a quadratic, a times x minus p squared plus q. Those are from pre-calc 20, I believe. Okay, so what type of function is part A? Linear. How do you know? Because it is of degree 1. Awesome. So degree 1, how many x-intercepts will this have? Okay, good. The number of x-intercepts is 1, because a line can only cross the x-intercept once. It doesn't turn back around. Now the y-intercept. The y-intercept, remember, is also your constant. 5? Negative 5. Good, because it's got a negative sign in front. The domain. Read the domain. X such that x is an element of the reals. Good. And the range. Why is y also an element of the reals? Good, because a straight line will go on forever in either direction. Then we need to talk about the end behavior. So where will this line start and end? Remember, is it positive or negative? It's positive, so that means it goes in this direction. Quadrant 3 to quadrant 1. And how many turning points?
0.
Good, 0 turning points. Okay, let's try B then. What kind of function is this? Quadratic, how do you know?
Because it's
Good, it has a degree of 2. And does it open up or down?
down.
Opens down. How do you know?
Because it's a negative.
Good. So the leading coefficient here is negative, which means it opens down. Then we need to talk about how many possible x-intercepts could there be.
0, 1, or 2.
Okay, 0, 1, or 2, right? Number of possible x-intercepts, 0, 1, or 2. Again, there's the cases that it could be above, on, or going through. Domain. So y-intercept is 8, domain. X is an element of reals because there are no restrictions. The range. It's quadratic. Okay, and does this have a min or a max? It has a max, so that means y has to be less than or equal to the maximum point. How many turning points does it have? 1. How do you know? Because it's a parabola. Good. 1 turning point, and the end behavior. Where does it opens down? So where does this parabola start? Good, and it ends in quadrant 4. Awesome.